Hey guys, PC Mecca here. Since the start of the year, we've built nearly a dozen gaming PCs. A couple of high-end ones, but mostly builds with a certain budget in mind, typically below $1,000. When specifically building a budget-oriented rig, one of the things you need to do is calculate your component's power requirements in order to both pick a power supply with enough wattage and also not overpay on your power supply. And to be able to do that, you need to know approximately how much power each component is drawing. If you are watching this video, you're probably wondering how much power does your motherboard use? Or simply how much power do motherboards use in general? We'll answer both questions, as well as give you some tips on how to keep your motherboard power usage to a minimum. But first, let's answer how much power do motherboards draw in general. On average, the motherboard itself will use anywhere from 30 to 80 watts per hour. This range depends on the type of motherboard you're using. Gaming motherboards tend to draw more power, as well as the current status of the motherboard. If you frequently overclock your components, expect the motherboard to draw in more power than if your machine is idle. As you can see, a high-end motherboard can draw almost as much power as a dual-core, even a quad-core processor. If you're looking to optimize your build for both performance and energy efficiency, it's a good idea to know exactly how much power your whole build will need, motherboard included. When the machine's active, however, it's a lot harder to know exactly what your motherboard is doing power-wise. There are two methods to try and validate its power usage. Refer to the manufacturer's website and perform some manual calculations, or use a software solution that watches power consumption live. Yup, that's all there is to it. Let's discuss a bit about the software solution. Depending on the manufacturer of your PSU, motherboard, or other components, they may offer first-party software that relays some information related to power usage back to you. For example, Corsair has a series of Corsair Link-enabled PSUs that allow you to see the temperature, fan speed, and voltage of the PSU. Other freeware and open-source software, such as HW Monitor and Open Hardware Monitor, attempt to provide third-party solutions that can read all the components' power usage at once. However, depending on the chipset you're using, these tend to not be a one-size-fits-all option. So, if the software is hit or miss, the alternative is to do some research on the manufacturer's website and use a physical energy monitor. Physical energy monitors typically plug into a wall socket and provide a pass-through for the power cable from your PC to the electrical outlet. To utilize this method, we recommend finding the expected power usage of your CPU, sticks of RAM, and GPU while idle. Again, this will probably have to be guessed based on manufacturer specifications. Once you have that information, disconnect any USB devices, Bluetooth devices, and the internet from your machine. This step is to remove any additional power being drawn by these items from the motherboard. Use the physical monitor to track usage over 1 hour, then take down the results. Subtract all the parts you are 100% certain of, don't subtract the motherboard, and the final number you're left with should be an estimate of the idle power usage for your motherboard. While this is super dirty to get to, we think it's a far more reliable method than using one of the software solutions. To go the other path, seeing how much the motherboard is drawing at its peak, you would follow a similar process. Use the manufacturer's site to calculate power usage for CPU, GPU, memory, etc. at max use. Plug everything you can into USB ports. Run a highly demanding graphical benchmark such as 3D Mark. And subtract the usage for everything but the motherboard after the benchmark ends. You may have to do some calculations to get to what the expected draw is per hour. So if it ran for 5 minutes, multiply the result by 12 to get the motherboard's wattage per hour. So now that you have a general idea of how much power your motherboard uses when idle and when under stress, let's take a look at what exactly makes the motherboard's power usage go up while in use. As you may already know, the motherboard is essential to every PC's function. Should it fail, you're pretty much rebuilding, unless you're very lucky. This essential tag comes from being the home of USB connections, the CPU, the GPU, any other PCI Express slotted items, and even wireless connectivity options such as Bluetooth and Wi-Fi on select models. The more the motherboard takes on, the more power it needs to continue to drive these functions. As such, the more USB devices are drawing power, the more simultaneous wireless connections, Bluetooth or otherwise, are made, and the more the GPU, CPU, RAM, or hard drives work, the more power the motherboard requires. That said, if you're looking to lower your motherboard's power usage, you can limit overclocking the GPU or CPU, turn off your awesome LEDs sometimes, and of course, unplug items from USB ports that are not being used currently. Again, since the draw is pretty small overall, the differences may not add up to much, but it's definitely the right thing to do if you're closely watching the power usage of your PC and your motherboard. That's it for today's video. Thanks for watching. If you guys have any questions, make sure you leave them in the comment section and we'll be more than happy to help you out. Lastly, if you enjoyed the video, make sure to share it with your friends, hit the like button, and subscribe to our channel to never miss a future upload.